All right, now that we have the ratios down and we've worked with them a little bit, you've seen how to set up the ratios. Now we're actually going to work backwards. And in the triangle you're looking at, the right triangle you were looking at, you don't know what the angle is. If you did, you'd be able to figure out the ratio. But in this problem, in the pink triangle, what they gave you was they gave you a side, 20 centimeters. Then they gave you another side, another 15 centimeters. And what you have to figure out in the problem is you have to figure out what theta is, the missing angle. So you have the three ratios in front of you, and ordinarily you would get the angle that you're looking for, and you just try to figure out the sine, cosine, or tangent using opposite over hypotenuse, for example, and you'd work your way that way. But in this problem, what we're going to do is we're going to work our way back to the angle by using the ratio. So ordinarily you're finding the ratio, but this time we're going backwards. So and there's got some really good applications you can do here, and without this part of it, there's a lot of word problems that you wouldn't be able to solve. So this is really the beginning of how do you isolate the angle? How do you know what the angle is? And the way it works is we're going to first take a look at the angle we're looking for. In this problem, we're looking for theta, which is right there in the corner. And we want to get the value of theta. How big is the angle? So you have a couple options here. What you can do is first see what you have. We don't know what D is. D is the adjacent side right here. We have no idea what D is, so that's out. I don't want to use that. I could figure out D if I wanted to using the Pythagorean theorem. 20 squared minus the 15 squared would equal to D squared. But let's work with what we have. We have the 15, which is opposite the angle, opposite theta, and we have the 20, which represents the hypotenuse of the triangle. So we really know the opposite side, and we know the hypotenuse. So ask yourself this question. Out of all the ratios you know, which one is comparing the opposite side to the hypotenuse? And if you look closely at the three ratios, the only one that has that relationship is the sine. So you should say, all right, well, I would like to use the sine to figure out this angle. You could also use the hypotenuse divided by the opposite sine. That would be the cosecant. But we're going to stick with the principal ones right now. So we're going to use the opposite side is 15. The hypotenuse is 20. So you could write, in fact, I would strongly recommend writing this, that the way you'd figure this out is the sine of theta, and let me just get a theta up there, theta equals, well, you know what it equals. Most of the time you're trying to figure out what it equals. In this problem, you actually know what it equals. In this problem, you know it equals, the opposite side is 15 centimeters, excuse me, and the hypotenuse is 20 centimeters. So you know that it equals 15 over 20. And if we wanted to simplify that, right, that would be 3/4. We could actually simplify that to be 3/4 if you wanted to. 5 goes into 15 3 times. 5 goes into 24 times. So we know the answer is 3/4 or 15/20. It doesn't matter which one you use. But we're trying to figure out the angle. So there is a way to back your way into it, and that's called the inverse sign. The inverse. You're actually going to take the inverse of the sine. If you remember early in the year when we did inverse functions, we switched the x and the y to find the inverse function. Well, that's really what you're doing here. You're switching the angle in the ratio. So the way you want to set it up, in your notebook, you want to write down this ratio. You want to write down the sine is what we're talking about. We picked the sine. But look at the -1 here that's being used. Just like we did earlier in the year with inverse functions, you're using that -1 to symbolize you want the inverse. You don't want the sine of the angle. You know the answer. You know the ratio. You're looking for the angle. So you're going the other way. You're switching the x and the y. So you notice that 15/20, that's the ratio. Think of it as that's like your answer. And that's going to give you the angle, the value of the angle. Now I actually have the answer on the screen, but I would like to show you where that came from using your graphing calculator. So again, the important thing to write down in your notebook for now is that you're finding the inverse of the sine. You're actually working your way backwards from the normal. Normally up here you would do the sine of the angle, where you would, like for example, the sine of 30 degrees, because you know the 30 degrees, and then you'd compare the opposite over the hypotenuse. In this problem, we're working our way backwards, so instead of theta being here, we do the inverse, we do the ratio first, and then it equals theta. So that's how we're going to figure out the angle. So let's look at the graphing calculator, and I'll just drag it over here. Okay, first thing you want to do after clearing the screen is make sure you're in degree mode. We're still talking about degrees. Remember, we're not going to cover radians this year, just degrees. So always double check your calculator before you begin any of these trig problems. Just make sure you're in degree mode for now. Okay, and the way you do it now, if you look closely, you see the sine, cosine, tangent on your calculators right there in the face of the calculator. But if you look closely above those keys, you will see the sine to the -1 power, the cosine to the -1 power, the tangent to the -1 power. That's what I wrote on the screen here. This is the inverse sine. That's how you pronounce it. Inverse sine, inverse cosine, inverse tangent. Well, to do this problem, all you need to do is go second, press the sine button, and the calculator is going to show you exactly what I have on the screen. The calculator is waiting for you to give it the ratio. What is the opposite side compared to the hypotenuse? In this problem, you can type in 15/20, and you press enter, and that's where the angle comes from. This angle is approximately 48.6 degrees, and that's where the answer is coming from. The theta is 48.6. Now I want to show you that if you did use a simplified version, if you use the 3/4, right, and 3/4 instead of the 15/20, well, 15/20 by using similarity is the same, is a bigger version of the same triangle. You're still going to get the same angle, it's just you don't know how long the sides are. In the original you use 15/20. In the smaller one, you're using 3/4. It's the same triangle, a different size. The angles are the same. The ratio is going to be the same. So on your graphing calculator, you'll see that if you do the inverse sine of 3/4 instead of 15/20, you'll get the same angle. And that's because the calculator it doesn't matter what the ratio is. It doesn't care what the ratio is. All it's doing is comparing the opposite side to the hypotenuse and saying, if you give me those two sides, if those two ratios, then the angle must be approximately 48.6 degrees. And that's how you work your way backwards. Now, once you know the 48.6, the next question that you might be asked is, well, what's the other angle? If theta is 48.6, how do you get the other one? And the way you would do that is you would simply take 90 degrees, because they're complementary, minus the 48.6, because I'm rounding a little bit. And so your other angle has to be 41.4. So that's how the inverse works. And your next, I'm done with the videos, but your next part of the unit is going to be to watch a PowerPoint. Now the PowerPoint presentation you're going to watch is extremely important that you go through that slowly. It's got some very nice applications. You're going to see how to set up the problem in a word problem, and then you're going to work your way through actually finding the ratios, and how do you use this inverse to back into the angle, and why is that angle so important. So that's what's coming next. Thanks.